Hi, this is Mrs. Kidman, and in this video, we are going to be discussing dilations of polygons and different shapes. So when we talk about dilations, I want you to think about what times in your life have you ever heard the word dilation? Well, for me, I know what I always think of when I hear the word dilation is getting your eyes dilated. And what happens when we get our eyes dilated is we start with our original pupil here, and then our pupil actually gets dilated to a bigger size, so that the eye doctor can see further back into it, see what's happening with the cones in our eyes, things like that. It's pretty cool. So what a dilation is basically it's either enlarging or reducing the size of a figure while keeping all of the dimensions the same. So we're not changing what shape it is. We're not changing the proportions of it. The proportions are the same. All we're doing is either making it bigger or making it smaller so that it adapts to our needs. And we actually do this all the time. Think about times where you get a new sign made, or like you are given a small template and you make something bigger, or you are adjusting the size of a photo to make sure that it fits in the frame that you need to. We do this idea of dilation all the time. Now in math, when we're going to calculate and figure out what those proportions are when it comes to dilation, what we have to care about is two specific things. First is this point called the center of dilation. Now the center of dilation is a fixed point that is not typically on our figures that we can use to then help us figure out that scale factor. Now, if we're given two figures, usually we're given a fixed point if it's on a coordinate system. Our fixed point is always going to be our origin. And then the last thing is that scale factor. And that scale factor is what is that proportion that we're adjusting it from? So our triangle is still proportional to the other triangle that we're dilating. However, is it 2 times bigger? Is it 5 times bigger? Is it 1/3 the size? What is that factor that we're going to multiply the original one by to get the new one? So there's kind of 2 different ways that we can look at it. If we have a center point, which means it's right in between the two, then those distances are the same. But typically C, or our fixed point or our center of dilation, is not a center point. So what that means is to find our scale factor, what we're going to do is actually take the distance from that center point, that fixed point, to the new shape, and divide it by that distance from the center point to our original shape. So for example, so a great mathematical way to say it is our scale factor K is a number such that the distance from C to P prime divided by C to P. So this little apostrophe here is called a prime. And basically what it means is that we're referring to this new version of our original point P. So we had this point on our triangle. Now we've got the same point on a new triangle that has a similar relationship. So let's take a look at this dilation and what it does. So first, let's talk about how we can find the scale factor of dilation and then decide whether it's a reduction or an enlargement. So remember that this one here is going to be our original, and the prime means that it's our new one. So again, how can we figure out that scale factor? Well, a scale factor is going to be from our center point to our new one, divided by the center point to the original one. So let's take a look at the example of this one. We've got our center point to our new one, which is 12, and we want to divide it by our center point to our original one, which is 8. Now we can simplify this, and we actually end up seeing that our scale factor is 3/2. Now anytime our scale factor is, so if our scale factor is bigger than 1, then that means that it's an enlargement. If our scale factor is less than 1, then that means we have a reduction. So in the case of this one, because 3/2 is bigger than 1, we actually enlarged it. And that makes sense, right? Because we went from this smaller safety pin to a bigger one. Now let's take a look at these paper clips. Now remember, P is our original and P prime is our new one. Well, just looking at this visually, we can tell that there is a reduction in size, right? Now by how much? How much did we reduce the size of that paperclip? Well, we're going to take the distance from our original one to our center point and put that on bottom, and then our new one to our center point and put that on top, and simplify, and 18/30, 6 goes into both of them, and we end up getting 3/5. Now because 3/5 is less than 1, we had a reduction. So that's kind of how we can look at that to see how that works. Now, the cool thing is we can actually use coordinate rules for dilation. Now, as mentioned earlier, if we are given an image in a coordinate plane and we want to dilate it, either make it bigger, make it smaller, whatever it is, we're going to use the origin as our centered point. And then our scale factor, what we'll do is just multiply that times the x and y value. So let's take a look at a couple of examples here. where we're doing this. So first we want to graph triangle ABC. It's got the vertices 2, 0, 4, 1, oh, not 2, 0, 4, 2, 1, 4, 1, and 4, negative 1. Okay, so this is our cute little original triangle. I did it in purple there. And now I'm going to do this next one in orange. So with our next one here in orange, what we're going to do is we want to enlarge it by a scale factor of 2. So what I'm going to do is take each of my points. So A prime is going to be 2 times 2 and 2 times 1. So A prime is going to be 4, 2. And so then my new point is going to be at 4, 2. And that's point A, just like how this one here was point A before. And then we'll do the same thing with point B. So B prime is going to be 2 times 4 and 2 times 1, which will give us B prime as being a point of 8, 2. I'm going to go over to 8 and up 2. And then lastly, we have our C prime, which is going to be 2 times 4. Oh, not a and 2 times negative 1. So as we multiply those, we end up getting that C prime is 8, negative 2. And so then we can go over to 8, negative 2 here. And we can, this is B, this is C, and these are all of our primes. And we can connect those dots there. And look at that. So our new triangle here, it has been enlarged by a scale factor of 2. And so you can see that that triangle looks 2 times bigger. And all we had to do to figure it out is multiply that scale factor by each of the values. So this works great when we have a scale factor of a whole number, it's going to get bigger. If we have a scale factor of a fraction or something less than 1, it's going to get smaller. And sometimes we'll actually end up seeing scale factors that are negative. And so let's take a look at one example here where we're going to make this one negative and see what happens. So what does this do here? As our scale factor becomes negative, how does that affect our graph? So let's start by plotting our original triangle here. So I've got negative 2, negative 1 is point P. We've got negative 1, 0 is point Q. And we've got 0, negative 1 is point R. So here is our original one. So P, Q, R. Now what we're going to do is we are going to change it by a scale factor of negative 4. So what that means, remember, when we're adjusting something in a coordinate grid by a scale factor, we're going to multiply it. So our P prime is now going to be negative 2 times negative 4 and negative 1 times negative 4. And so P prime is actually going to be 8, 4. And then we've got Q prime, which is going to be negative 1 times negative 4 and 0 times negative 4, which will actually end up getting us the point 4, 0. And then lastly, we have R prime, which is going to be 0 times negative 4 and negative 1 times negative 4, which ends up getting us the point R, 0, 4. Okay, so then as we graph this, we've got 8, 4 over here. We've got 4, 0, and we've got 0, 4. Okay, now labeling these points here. This is R, this is Q, and this is P. So what happened? Notice when we multiply by a negative scale factor, what it does is it reflects it across the x-axis, and then it enlarges or reduces it. So a large reduction, things like that. In this case, it enlarged it. So really what that pattern is if we have a positive or a negative scale factor, if it's bigger than positive 1 or less than negative 1, so a bigger number than negative, like a 3 negatives, 4 negatives, things like that, then what it's going to do is it's actually going to enlarge our figure. But if it's between negative 1 and 1, so it's a smaller factor, not including 0, then what it actually does is it reduces it. So this is super cool. Again, that negative, all it does is it reflects it across that x-axis, and then we continue on with our enlarging or our reduction. And that is how you can dilate a different figure depending on what it is. Now, the cool thing about dilation is that we actually see dilation so often in the real world, and we just don't realize it. So for example, here's a problem where you're making your own photo stickers. Your original photo was a 4x4. You must have taken it on your phone. And the image of the sticker that you're trying to print out is a 1.1 inch by 1.1 inch. What's the scale factor? So how much am I reducing this by? Is it an enlargement or a reduction? Well, because I'm going from bigger to smaller, it seems like it's a reduction. By how much? Or on the contrary, you're using a magnifying glass and it shows the object is 6 times bigger than the object's actual size. So given that we're looking at this spider through a magnifying glass, how much bigger are we seeing it than it actually is? Now we can visually see, but that magnification level on there is really telling us I'm dilating or enlarging my shape by this many times. So my spider is 6 times bigger through this magnifying glass than it would typically be. Or my microscope might have it 100 times bigger or 1,000 times bigger, whatever it is. And so we actually see this all the time in the real world. Or that zoom feature on your phone. Have you ever considered that that's really just dilating something? As we zoom in, 2 times zoomed in means it's 2 times bigger than what it sees in the original photo. Or the controversy, phones now, you can zoom out even more. And what it actually does is it reduces the size of things that you see. Now it kind of distorts the outside edges of your photo, but we can actually reduce that size. So dilation is something that we do all the time in our lives. And it's so important to be able to know, how much am I dilating by? How do I need to affect this so that I can get the actual product that I want? So that is how you can use dilation of a figure, whether it's in a coordinate grid like we saw here, or it is just analyzing the difference of shape. We can find that scale factor by looking at the difference in by taking that center point and looking at the difference in the lengths, and then use it to determine that scale factor. How much did it change by? Or if we're given the scale factor, we can use that to determine how it affects it. If you have any questions, feel free to reach out, but that is how you can use dilation on different figures.